Hello and welcome to another tutorial. So this time around we are going to be building a serializable version of the dictionary. So the standard dictionary in Unity is not able to actually be serialized. You can serialize lists, however, so there are ways to work around it. So what I want to set up is the serializable dictionary. Now, a dictionary that can be serialized, that's actually the easy part of it. That's actually going to be pretty much the trivial part of it. The bulk of what we're actually going to need to be doing is making the inspector side of it work. That's actually the much more involved part of this. So that's where we're going to be focusing a lot of our time. Now with that, there is going to be, for this, few constraints. So one of the big things is a lot of what I'm doing is only going to be working in more recent versions of Unity and with more recent versions of the UI toolkit. So I am going to build this in UI elements because there are parts of this that it makes a lot easier and makes the code simpler. So the catch though with that is they do have sort of a restriction there that those features I'm needing are only available in more recent versions, unfortunately. So let's dive on in and start actually building this. So first thing that I need to do, obviously, is I need to set up a couple of scripts. So I'm going to, for this, create a folder that I put all of this in. So what we will have is, outside of that folder, I will have my test script for it. So this will be dictionary test. I'm just going to create an empty game object that I place that on. So that's good. And then in our serialized dictionary folder, we're going to have serializable dictionary. So that's going to be the actual sort of part of it that handles storing of the data. And that's actually going to be, like I said, quite a simple part of it. There's very little to that, to be honest. And then the final thing that I need to create is, because we need to have a custom editor for this. So what I need to do is I need to create a folder called editor. And then what I'm going to do in terms of naming this, so this is actually going to be a property drawer. So we have serializable dictionary property drawer. Actually, I'll just call it drawer. Serializable dictionary drawer. And because this is using the UI elements, I usually put UIE in the name there as well, just to make it stand out. So that's good. We will zoom in a bunch though to make it so that this is all nice and actually legible, because there is a bunch we need to set up. Okay, so the first thing I'm actually going to build is the serializable dictionary itself. And so there's a lot of different approaches for this, and I tried out a few different ways of approaching it and considered a few other ones that I didn't actually even prototype because they didn't sort of feel like the right fit. So the key things for me was in terms of what I wanted the user experience for this to be. And so the big thing there is, if someone is using this in a new code base, if they're familiar with dictionaries already, then I want this to work in the exact same way. If they've already got things that are a dictionary, the ideal is that they can just do a search and replace and it works. So whatever I did, it was pretty important that I made sure it was actually a drop-in replacement for the existing dictionary. Now, there are a couple of ways that I could go about doing that. One is that I could go and use sort of a composition approach. So have the dictionary, the normal C# dictionary, as a child of this, and I have this implement the dictionary interface. That was one option, and one that I did consider, but that was not looking like it was going to be super viable, because one of the big things there was it would be very easy for me to miss something that potentially created a bit of a maintenance overhead of, if that interface changed, needing to go and modify this class. So that was something I wanted to try and avoid. I did consider fully replicating the interface, but again, similar issues there. What I ended up settling on as sort of the option that I feel works the best is setting this up so it actually inherits from dictionary. So what I'm going to do is make this a generic value type. And then I'm going to say, rather than mono behavior, this is going to inherit from dictionary. I provide my key and value type like that. Now, because I want to hook into how serialization happens for this, what I do is I also say that it implements this iSerialization callback receiver. I also mark this as system.serializable. So I'm going to implement that interface. Now we'll get to the content of that in a second. So then, okay, we need to deconstruct essentially our dictionary. So what I'm going to do is I'm going to maintain here, and for now I'm going to have these as public. We'll do a bit of a test to see if we can actually change it away from that later. This was something that I did run into when working with this, of when I didn't have this public, I was actually getting errors that were happening deep down in the UI element system. So I want to try and avoid that. So we're going to have serialized keys. Create that as a new one, and similar for values. So, okay, that's a good starting point. That's the core data that we're needing to save with this. Okay, so with these set up, in the on-after deserialize, that's where we actually want to do a bit of logic. The on-before serialize, we're going to have that there, but we actually won't need to have any implementation for it. And this was something in regards to sort of managing to make things work nicely with the UI, because there is a bit of a battle there of timing of things and the order of operations of how things work, because when you're editing things in the inspector, these methods tend to get called a lot as well. So it can be really tricky to actually sort of maintain the integrity of this data. So that's why you won't see me put any code here that actually is going and populating the keys and the values from the dictionary itself. That's actually a very intentional thing. There's kind of no way around it. It has to be done via the inspector or via a specific method that I'll actually set up. So let's get this set up. So what I would do is we're going to create a bit of a synchronization function. So this is going to be public void synchronize to inserted data. Serialized data might actually be a better term for it. So the job of this function is to take the content of these arrays and actually populate that into our dictionary. That's sort of the purpose of this. So what this is going to do is, firstly, it does a clear. So it erases the content of the dictionary. Then F serialized keys is valid. So if it is not equal to null, and our serialized values is not equal to null. So if we have valid data, then build the array. We'll build the dictionary. If somehow those weren't initialized, what I would actually want to do is serialized keys. We knew that, and we do the same with the values. So f, for whatever reason, either of those were null, we reinitialize them. The other thing I want to handle is f serialized keys. If the count does not exactly match the value count, then somehow these have gotten out of sync. Now, this, with how we're setting things up, this actually shouldn't be able to happen. But this is a good safety measure because we're actually in the inspector kind of working with these two arrays separately. There's a little bit of logic we have to do to try and ensure that essentially maintaining the integrity of these. So what I'm then going to do is, if they don't match, then serialized keys is going to be equal to a new, and we can just provide keys, and we can do the same thing with values. So that will just resynchronize those. Now, potentially, we could do similar here if those are out of sync. So that's something where, okay, if we have content in the dictionary but not content in these, we could do that, but I don't think that's actually necessary. So if the lists are out of sync, then rebuild. So all I need to do here is we store off the number of elements. Now, because again, those arrays could have different amounts of entries, we're going to actually only put in the bare minimum. So then what I do is loop through index 0, increment our index like that, and then all we do is this on the serialized keys at that index. So we just set it like that. The other thing that we then want to do is this synchronization function. We actually run that here. So we always synchronize to the serialized data. We don't synchronize from it. What I'm going to then do is I want a editor-only function. So because we might be doing some custom editor logic and adding to this, what I'm going to do is have a public void editor only add, and that we provide the key and we provide the value. What we then do is we add that key, and we also then add the value. Now, what I would do is that's actually going to be, should already be in the dictionary. So I want to be a little cautious with, extra calls to synchronize or update the dictionary. And this does admittedly look weird. It absolutely does. And a large part of that is down to having to work around some weird and annoying behavior with how things work for the inspector. So, okay, the big set of logic is actually going to be for this property drawer. And so with this, we're working with UI elements, and that has a very different way of working with some of the things. And there's some stuff that we need to set up with this that looks quite weird. It is stuff that is a modified version of what Unity has made available in their guide. I found that I needed to modify it because there were some things that were specifically an issue. There was also some unnecessary stuff with it. So, okay, I need to essentially create something that's going to be able to act as a bridge for marshalling the data between the dictionary and the format that the UI element system needs. So for this, what I need to do is I need to create something called a UXML attribute converter. So what I do is I'm going to create here a public class, and this I'm just going to copy and paste this because it's just so much to type every time. So this is our serializable dictionary converter. This has the same template parameters. And what we say is that that is a UXML attribute converter for a serializable dictionary that takes key type and value type. So that's a key thing that we need to set up. Now, this has a bunch of interfaces, or a bunch of things that we need to populate for this. And this is not stuff that I needed to come up with on my own. This is directly from Unity, but I'll talk through as I build the stuff what sort of it's actually doing. So one of the things that I need is I need to implement this value to string setup here. So this takes, and it's an object type, so it's that base type in C#, and that maps to, we do a system convert to string in value, and what we indicate is that this the culture info is an invariant culture, and it didn't actually auto-populate. This function has a lot of parameters to it, so this might be system, I think it's system globalization.culture info.invariant culture. So I'm going to actually just using that in, because otherwise that is a gigantic line. So we'll bring that in. We're only really using it for that particular thing, but it just makes that a little bit neater. So the idea of this is a static function that is going to be able to convert a particular value to a string. Now we have the sort of key override functions we have to implement. So the first one is we're implementing the toString method. And this is a toString that can take our serializable dictionary. So the idea is that this can convert from our dictionary into a single string. So what I do is I have our data builder. This is where a string builder is super handy. So that's good. And at the end of this, we'll return data builder toString. So what I want to do then is I want to take the content of my dictionary and I need to convert it to a string. There is a very specific format to this. So the UI element side of things is expecting things in a very particular way. So this needs to be precise. So that's why the formatting, you might want to go and actually change it, but it's very important not to actually change the formatting of this. So we loop through the data, and then we do our data builder, we append, and then what we construct is firstly we do value to string, and what we pass in there is the key, so our KVP key. That's the first thing. Then we do the pipe symbol, and then we do a value to string, unsurprisingly, of the value. And then at the end of that, we put a comma. So that's all we need for that function. So that's going to iterate over the entire dictionary, and it is going to convert all of the elements of it to a string, which is good. The other thing we need to then implement is we need to implement the function that goes the opposite way. So we need to implement the function that goes from a string. So how that function looks is we have our public override. Now this returns a serializable dictionary, and I'm going to in source for that. So now we need to do the reverse of this. So what I'm going to do is firstly create our new dictionary. Well, this will be our output dictionary. So we've got that created. Then what I want to do is our key value pairs. We take our source and we split it. Then we loop over our key value pairs like that. We get rid of the throw there and we can return output dictionary. So we loop over all of those pairs. Now we need to split those up. So our fields is our source, our KVP, and we split that. In this case, we split it using the pipe symbol. So then our key is what we can actually just do is key type. Key is a system convert, and we do a change type from fields to our key type, and we need to also put key type like that. And then we do the exact same thing for our value type. So value type, so this relies on whatever we're using as our keys and values being able to be converted to and from a string. So that's something that, fortunately, unless you're using something really exotic, is likely to work completely fine. But that's just something to be aware of that you may run into, but we can test that and see what things it might break with. But that's good. So we've extracted out the key value pairs, we've extracted out our individual key and value. Then what we can do is we can get here and we can say, okay, well, our new dictionary, our output dictionary, we use our editor only add for the key and value. And then at the very end of that, we force a synchronization. So that's good. That's going to allow that sort of bridging over to the UI element side of things. Now we can actually implement our property drawer itself. So this inherits from property drawer. We get rid of our start and update. We are going to say here, okay, well, this is a custom property drawer for type of serializable dictionary. Now, the way we need to specify this is the angle brackets are empty apart from the comma. And we want this to support any child classes as well. So, okay, so far so good. Couple of bits of data that are going to be useful for me to cache is I want to have some serialized properties here. So we're going to have, for the actual linked property, have another one for linked keys, and another one for the linked values. So we actually have all three of the same type, but they're linking to the actual dictionary and then to things within the dictionary itself. So the next thing we want to do is set up the basis of our actual drawing. So we're going to have an override, and we'll have visual element. So we'll see if that's, yep, that is working properly, so that's good. So, okay, this is our create property GUI. So first things we're going to do is, okay, well, our linked property is our in property. So I'm going to just rename this just so we're consistent. Then we need to get our keys and our values. So our linked keys is our in property, and we do a find property relative. Now, the name that we give here has to exactly match this name here. It has to be exact, like that. Same thing for with the values. It has to match. Otherwise, it's just not going to find it, and then everything is going to really just not work. So that's good. So we've got our property, we've got our values. So far, so good. What we need to then do is I'm going to set up sort of the base for the actual visual element container here. So I'm going to have our container UI, and that's a new visual element. And that's actually what I'll return at the end here. Now, initially, we're only going to have essentially a single thing populated into that, and that's okay because there's going to be additional things we do later on to extend this and to improve it. So what I want to do is, okay, my dictionary, actually I'll call it the contents UI. That is going to be a new list view. So we set up a new list view, and then we're going to configure a bunch of the settings for it. So for this, I want to have the add remove footer visible. That's going to be a useful thing to have present. I do want to have a border for it because I think that's going to help it stand out. We also have an option for show alternating row backgrounds. That's one where I would actually do that for all of the things. A few other ones that we want to configure with this. We're going to, there is a, oops, comma for it to autocomplete, a show fold out header. So there's a lot of different options that we can be configuring for this. And just the main reason for this is really just to have it that it's going to be sort of a presentation that we want for this. I want to turn off showing the actual size. So I'm going to turn that off. That's not something we need. I also don't want it to be reorderable because it's a dictionary. So reordering it, I feel like doesn't make any sense. You might, it would reorder the, key and value lists there, but if something happened that it needed to regenerate them, that order would be thrown out. I just don't see the need for having it reorderable for a dictionary. The other options we need to do here, a few of these are going to seem weird. So this needs to be a dynamic height. So I don't know, virtualization method is a weird naming for it, but essentially we're saying that its height is going to be variable. The title for it, well, we have our property and its display name, so we can use that. The binding path, this is how we actually bind it to our particular set of keys. So that is our linked keys and the property path. So we bind it via the keys. We'll directly work with the keys and the values, but the one that it's actually bound to is going to be the keys themselves. And then the bind item. So bind item is our way of actually generating the little UI element for the particular individual items in this. So that's going to link to a function that we haven't set up yet, but that we will set up in a moment. So then that container UI, we add our contents to it. So that looks good. We'll set up our actual bind function now. So what this looks like is we have bind list item. This takes in a visual element. So this is the visual element that will contain the particular item. It also gets told the item index, which is actually really handy because that's going to allow us to be directly working with the particular sort of properties, things like that. Now, the first thing we do is we actually clear out the UI. So we reset the item UI so that it's something that we have fully configured. Going to then do is I'm going to actually get the particular key. So our current key, or our item key, I think would be the appropriate term for this. That we take our linked keys and we do get array element at index from that index. So that's the item key, and more accurately, that's actually the item key property. Because it's not the particular value of it, it's the property that is mapping to it. So what I'm going to then do is, okay, well, we have our key UI is a new property field, and we bind this property field to that item key property, which I might just call that key property. We'll also do a similar thing and extract the value property, and that's going to then be a linked value, sorry. Again, a get array element at index, item index. Unsurprisingly, the property UI, well, sorry, value UI is constructed in an almost identical way. So we use property field, so it'll just actually go through all of the normal logic, be able to be working with all manner of different types. It just largely figures it out for us, which is really handy. So that's good. Then what I'm going to do is in item UI, I add our key, I add our value, and then I don't do a return. I take our item UI and then I bind it to, we get our linked property and the serialized object. So this is something where if you haven't worked with UI stuff, a lot of this stuff when you're doing your serialized objects and serialized properties and all of this does look very messy. Part of this is because when we're working with the inspector UI, we intentionally want to have things abstracted a bit. So we have these wrappers around our properties, and those wrappers handle things like notifying undo systems of changes, being able to manage and marshal all of that information. So it adds a little bit of mess to it. It definitely is a bit sort of confusing, but it does make it a lot easier for being able to work with. So, okay, that's good so far. That's going to get us a large chunk of the way there. One of the things that we do need to do is we also, we had to substitute our custom logic for binding to the list items. We actually want to override the add button behavior, and we will in the end override the remove button, but not initially. So this ends up linking to an onAdd button function. So this is another function that we go and actually sort of set up. So what this looks like is onAdd button. Now this takes in a base list view. It also gets the actual button itself, not that we need to do anything with it. What this lets us do is we can go linked keys, insert array element at index, and we insert it at linked keys dot size, or array size, so it puts it at the end. We do linked values and do the exact same thing. So linked values, array size. Really important to make sure that keys is referring to keys array size and values to values. Again, those can get out of sync, but we've put stuff in the dictionary itself to bring those back in sync if they've accidentally gotten out of sync. And then our linked property, we tell the serialized object to apply those modifications. So that's good. That should be enough that we can actually test with our dictionary. So what I'm going to do here is I'm going to create Serializable Dictionary, and I'm going to have a few different ones. We're going to have one that can go from a string to a float. We're going to have another one. We want to try a few different things. We'll have a string to a vector 3. So string to vector 3 map. Let's add in a little bit of additional complexity, and let's have something that goes from string to game object. And this will be string to game object map. And then finally, let's have one that goes the opposite way, and it maps from a game object to a string. So we're setting up a few different ones here, all things that should serialize fine, and things that we normally can serialize in the inspector okay. But we are also testing where we've got a mix of values and we've got a mix of structs and classes. So there's a mix of different things there, which is what we want with this. So, okay, I want to see what that looks like now when I select the game object. So I can select it, I can see the different maps here. I can expand this. So our string to float map, let's add an entry. So this could be, low, and that might be a value of 1. We go to add, and we can see this follows the default behavior that Unity does with lists, where it duplicates the previous entry. Medium, we might make that 5, and then add in high, and that can be 10. So that looks good. We check going back and forth from it that, yep, that's correct. So that looks all good there with that. But the thing is, we do get duplicates, and we want to see sort of what happens with that. So let's start by setting up here just a helper to log out essentially the content of all of these. So what I'm going to do is for each AVP in our string to float map, and we will just debug log AVP key equals and KVP value like that. And we will just first log out. I'll make this a log warning so that the grouping, we can easily sort of see that. So this is string to float map. So that looks good. And all we're going to do is make it so that all 4 of those maps that we've got, all 4 dictionaries, are logging out. Just so we can test and see what do things look like with duplicates. Because the way it works at the moment, we actually should get duplicates. And worse, we'll actually probably get a case of data stomping over other ones. So let's run this. So we don't get any entries for the others, that's expected, but let's test that we can link things up to those. Let's actually populate some entries here, origin, and we'll make a forward. I've been working in Unreal a lot, so I really hope that I guessed right that Z is still forward in Unity. So used to Unreal and switching between the engines that I need a set of axes sitting on my desk, actually. So I have our camera, and let's link that over. Let's link up the light. And then let's do another one here where this is going to link the reverse way. That's camera. And that's light. So we've got a bunch of entries, a bunch of different types there. Clear that and run it. So we can see our string to float map appeared correct. Our other maps all look correct. Let's intentionally create a duplicate entry now. So our string to float map, I'm going to add another entry. And so now if I run this, we still only have 3 entries. But which one of these is it using? Let's say I add that duplicate and I set it to 20. It likely is going to take that last entry, and we can see it does. So this is the problem with if duplicates end up in there, that it's going to be doing stomping of data. So what I want to actually add to this code is I want to make it that it can detect that there are duplicates and that it can actually give us some helpers for cleaning things like that out, because that's going to be something that is going to make our life a lot easier. And this was sort of one of the big challenges I found with setting this up, was making it work to avoid duplicates. So the bind list item here is first place I want to actually do some modifications. So we're adding in, our key and value UI, things like of that. What I want to also then set up is our warning UI is a new label. And what this is going to be is we'll make this bold. Bold text, and we're going to say error duplicate key detected, like that. Close out that being bold. I'm going to add that into our item UI. But what I want to do is I want to be able to specifically check if there are actually duplicates present. So my warning UI, whether that's visible initially, I'm going to set up this function, are duplicates of key present. And what we'll do is we'll actually give this the key property. And what I'll also do is, because that index will make things a little bit easier, we'll provide that. Now I want to be able to have this react to when there's changes too. So what I'm going to also do is our item UI, I'm going to use this track property value. I want to be tracking that key property for if it changes, because I don't care if the value changes, but I care if the key itself changes. Then we get our serialized property. So we get this little callback that gets run. And what we do, it's actually pretty straightforward with this. We can just duplicate this line here. It just needs to do a refresh, essentially, of that. So the idea behind this is so that we can always keep that refreshed and keep that in sync. So far so good. I need to set up this function for if there are duplicates of the key present. So we have serialized property in key property. Then what I'm going to do is we also get our key index. So to know if there are duplicates, what I'm going to do is loop through all of the keys. So we loop through, index is 0. Our index is less than the array size of the keys. Now, if the index is the same, we skip it. Skip if this is our key. So if index is equal to our in key index, we just do a continue. Otherwise, what we do is we get the other key. So we retrieve that from the particular index. Now we need to compare these. Now we don't want to just do an equals. What we're actually going to do is we want to check the underlying values. So I'm going to say if other key dot boxed value is equal to our provided keys boxed value. If that's true, then we return true. Otherwise, we return false. So this gives us a way of being able to highlight those keys that are duplicates. So if we go to this now, we can see we get warnings for both of these that they're a duplicate, and we should show it on all of them because we don't know which one's necessarily the correct one to actually remove. So that's good. A couple of other things then we want to do with that is we want to provide some helpers for cleaning that out. That'll make it easier. I'm also going to override and set the label for these. So we'll have that for key, and we'll override it for the value as well. It just makes it a little bit neater. It means we're not seeing, element 0, etc. Not really super friendly in terms of display there. So that's good. We need to have a helper for removing duplicates though. So what I'm going to do is up in setup here, and this is why we split out the container UI and the contents UI, because I'm going to set up a remove duplicates button. Here's a new button. The text for that is just going to be remove duplicates. Very straightforward. I might also do that just on the one line, given it's relatively short. Keeps it a little more neat and contained. We do obviously add that to our container UI, but the big thing is our remove duplicates button. When it's clicked, I want to run our on remove duplicates function, which we haven't actually created yet. So that's the final thing we want to create, at least as far as this part of stuff. There is going to be a couple of other things we need to add in, but we're going to do this first. So we have remove duplicates. Now this, we need to do a nested loop because we need to loop over all of the keys, and then we need to loop over all of the rest of the keys. And what we're going to essentially do is we only keep the first instance. Now, because we're modifying what we're iterating over, what I'm actually going to do is have a list here of indices to remove. We're going to loop over our index here. Now we loop over through all of the keys. We get the serialized property for this first key. So that's our linked keys and our get array element at index. So that's our first key. Then we have our other index, and we can start this at index +1. We loop over until we get to the end of the keys array again, and we increment it, so nothing unusual with that. We again pull out the other key, this time making sure that when we get the array element index that we use other index. That's something where autocomplete can easily make things go wrong there, so we want to be very careful to make sure that it doesn't. So just always be careful with the autocomplete. And I say that because it has bitten me so many times. So then we want to compare the values. So we check, okay, well, the first key boxed value is equal to other key boxed value. Then our indices to remove, we add the other index. So that's good. That will fully populate those entries there. Each index should only be able to be added once, which is ideal, although conceivably I could see how it could end up adding in multiple ones. So I think just to be safe, what I'm going to do is also check here that indices to remove, we'll do a contains check for the other index and make sure that it does not contain it. So we only add it if they match and it doesn't already contain that other index, just as an extra safety, because maybe if things go slightly wrong, it could end up with duplicates there. And this isn't a performance critical code path, so we can take the time to do some slightly slower checks and make sure that the code is being safe. Then it's pretty straightforward. We can loop through our indices to remove. And what we do is we go linked keys, and we can tell it to delete the array element at the index. We do the same thing with the values. We do the delete and our index to remove. And then at the end of that, we get our linked property, serialized object, and we apply. So that's good. Move the duplicates. And what we're doing here is search for any duplicates. So that's good. That's going to give us a button that will allow us to easily remove any duplicates that we might actually have there. So that's super helpful. So, okay, so far, so good. So, okay, let's see how that works. Got our game object here. I'm going to save everything and see it's detected duplicates. Let's tell it remove duplicates. And we can see that's cleared out. We can save that now. And then if we run this, it's just saying the correct values. We can also see as soon as we go to add one, it's correctly flagging it. But if we rename this, then that's going to update. Now, it doesn't immediately update previous ones. That is the one sort of slight limitation there. We likely could do a couple of updates to maybe fix that, but it does at least flag the duplicates and it does pick up when there are ones there that need to actually be fixed up. So that's good. So if we take a look at this, we will notice we do get a little bit of odd behavior seeming to happen here with when we go and actually remove things. So if I add in a couple of additional ones, we do get some errors here with when we're adding in stuff. And I'll find when I go and delete stuff, it's actually going to remove more than it should. So we're getting errors, we're getting weird deletion, stuff like that happening. If I add in one, it's fine. Add in another, like I can keep adding in ones, but then as soon as I delete something, multiple get deleted, and that's weird. And if I look at the actual file, it does show that multiple got deleted. It only is showing, this is the actual scene in the data, it's showing only those particular ones. So it's behaving pretty weirdly there. And if I add in a bunch of ones and save that out, we'll see, okay, does correctly add in all of those. But then when I go and picking probably any of these and remove, it removes multiple. And if I save it again, they're gone. So the way it's handling removal is not really behaving the way that we would want. We want to be able to select an individual item and remove it. So what I'm actually going to do is I am going to, similar to how we overrode stuff with adding, I'm going to have on remove, and that's going to go to our on remove function. Now, our on remove function, what we set up here is this is a void on remove. Now, all this gets in is the list view, and that's okay because that's actually all it needs. So what I would check is, okay, well, do we actually have values, for one thing? So linked keys, array size needs to be greater than 0. That's a given. We also want to check, okay, have we got a valid item selected? So, okay, is our in list view selected index greater than or equal to 0? And we also then want to check, I'm going to put these on separate lines to make it a little bit clearer. Because what we'll check as the final thing is, okay, the list view's selected index should be less than the array size as well. So a bunch of validation checks, but they just ensure that we're actually working with this correctly. And then it's pretty straightforward because we've actually conveniently already got the key bits of logic we need up here. So rather than being here that, our index to remove is our in list view selected index, like that. So that looks good. So let's test that and see if that behaves better now. So if I go and add in a bunch of additional entries here, and I modify one of these, then what I can see is I can select that particular one, and I just remove only it. Or we can do remove duplicates. Now that does give us an error here. So we do want to check when this is going and removing things. Our indices to remove, we actually want to process these in reverse order, because what would be happening is we would actually be deleting more things than we should. So I'm going to reselect that, manually delete that entry. Good, we've cleaned that out. So, okay, we need to fix the logic that this is following. So there's a few different ways we could go about sorting this. One of the easiest options with this is to just loop through this in reverse order. So for index is our indices to remove, count -1, select that. And then we say index to remove, create that. And that's just pulling from that setup. So that should fix the issue where it was trying to remove multiple of the same thing, so the duplicates were getting confused. So we're going to add in a bunch, make sure we can remove duplicates. That worked cleanly, so that's good. Just save that and recheck it again. That looks good. So add in a bunch of ones. We make sure we can delete specific individual one and then still be able to run remove duplicates, which we can. So that looks good. So we've fixed that particular problem. Let's make sure we can still add things in. Now this does give us an error at this point. So the final problem that we need to fix is if we add in a bunch of entries here, and if I remove one of them and then go to add, I get this error. And we can see the error is coming from here. So we do clear the item, but because the item is getting reused, what I also need to do is I need to unbind it. So I remove any of this actual tracking stuff that's already been set up. What I should now find is that I can get here and I can remove entries. I select one and remove it. Remove a bunch of ones, and I can add in ones, and those are working fine. I can go and remove duplicates. I can add in one, give it another value. So all of that is working. I can delete that, so I'm not getting any errors whatsoever. And if I run it, I can see that I'll get the output correctly for those particular values. So that's good. We've got our dictionaries working for being able to be serialized. We can throw in a couple of other sort of test ones if we want to try some more complex types that we might not have initially sort of used. So we could try, okay, does it work with colors? Do the same logging out. We really just want to make sure that it works with a good range of types. If it works with floats, we know that it's going to work with integers. Working with vectors is good. That's going to cover a lot of stuff. The fact that it works with game object as well means that it's going to work with a lot of things. So far, it looks all right. You can see we can add in entries here. Color picker properly gets invoked. All of that seems to be working the way we would want. Can remove duplicates. So everything's behaving quite nicely there. So the final thing that we want to fix up is this fact that the remove duplicates there ends up being, not inside the foldout. So what I'm going to do is I'm going to change this so our actual container UI there is a foldout. And we're going to set its text to that in property, and we use the display name. So that will make it a foldout. We remove the foldout header from our actual list view. Now, if we do just that, what we can see is they are fully expanded. So all of that is sort of working. But the thing that we would find, and just want to test, it nicely works. Everything there is behaving the way we would want it to, but it doesn't remember the settings. It resets that every time. So the way to actually make it remember the setting, and this is a little bit odd, is we use this view data key. Now with this needs to be a string that is going to be unique that we want to generate. So the easiest way to do that, and this is something that credit to FEP310 on the Unity forums for this. I'll put a link to their comment actually in the description because their description worked perfectly for this. So what we do is we take our property, we get the serialized object, the target that it's referring to, and the target will have an instance ID. And then we also append to that our properties name. Like that. What we should then find is that this will actually remember these. So if I collapse all of those, we'll leave the string to color one not collapsed. Select away, come back to it, and it's actually remembered it, expand it, come back. So it's remembering the state of the particular ones, which is what we want. That's how it all should actually behave. So that's good. We have our serializable dictionary up and running. We have the custom inspector for it. We can work with it in code. We have tools for detecting and removing duplicates. We've done custom handling for things like adding and removing to make sure that that works and that that behaves correctly. So we've got a solid system now that we can make use of that is able to handle a variety of types. We may run into some types that it's not going to work with well. Most likely scenario we'd run into that for is if there's anything that doesn't have full conversion set up to and from strings. So that's something to be aware of, that you might need to make sure that that is something that you have properly implemented for anything if you're using a type outside of sort of the standard usual ones. But dive on in and experiment with this. See what you can do with this, see where you might want to be making use of your serializable dictionary. It is something that comes in really handy, and hopefully Unity's going to add in their own version at some point that will be even better than this. So folks, hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. It really helps out. It's really appreciated. If you're looking for the code for the project, the code is available up on GitHub, and there is a link to that in the description below. If you have any questions, chuck those in a comment. And if you are looking for other ways to support the channel, then I do have a Patreon, and there is a link to that in the description as well. But until next time,